In question 22 we've got two triangular prisms and we're told that they're mathematically similar, and that's really important because what it tells us that them being similar is that their lengths are in proportion. So whatever the ratio is of that length to that length will be exactly the same ratio of that length to that length. So straight away we can see that if this is 6 and that equates to 12, so it doubles. So if this is 15, we straight away know that will be 30. So without even knowing what the question's asking me, I'm just going to put that in there, because whether it's needed or not, it helps me just understand the makeup of this prism. So we've got, it's very badly written, let me just rub that out, write it again. So we've got 30 there. Now the other thing about mathematically similar shapes, where their lengths are in the same proportion, the areas are in the proportions squared, the volumes are in the proportions cubed. So what that means is, if we look at the information that we've been given, we're told that the area of the cross-section of prism P, this bit here, is 10 centimeters squared. They want us to work out the volume. In order to work out the volume, we need to get this area here and multiply it by this length here. So what I said earlier was the proportions will be squared for areas, cubed for volumes. So we know this here is 10 centimeters squared. We know that the proportions here go from 6 to 12, so they double. So the ratio is 1 to 2. The ratio of the volume, not of the volumes, of the area, sorry. The ratio of the area will be 1 to 2 squared, which is 1 to 4. So what that means is, if my area here is 10, this one will be 4 times greater, so it's going to be 40. And I'm not going to put the let me just put the centimeter squared, usually takes up space. So that's 40. So now I know, in order to work out the volume of this prism, I need to do 40 multiplied by the length, which is 30. So we've got 40 multiplied by 30, that's going to give us 1200. So 1200 centimeters cubed.